Section 1.8 is titled Introduction to Functions. A lot of vocabulary terms here, and hopefully most of these you know, but a coordinate plane is formed by the intersection of two perpendicular number lines. The axes are those perpendicular number lines that form the coordinate plane. The origin is the point of intersection of the axes. The x-axis is the horizontal number line. The y-axis is the vertical number line. An ordered pair is how a point on the coordinate plane is described, and we use x, y. A quadrant is one of the four sections of the coordinate plane that's created by the axes. So let's look at a coordinate plane. This is a coordinate plane, and let's label a few things. If we go back, we want to look at the axes. Here are the axes. The y-axis here, labeled y, labeled y, and the x-axis here, labeled x. The origin is the point where the two axes intersect, so that's the origin. And let's also label the quadrants. There are four quadrants on a coordinate plane, and we start in the upper right-hand corner using Roman numerals. Then we move clockwise around. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You'll want to be familiar with that labeling system as you'll have to do it on your homework. So let's graph the following points. Remember, when you're graphing an ordered pair, the first number is the x, or how far you move in the x direction, and the second number is the y, or how far you move in the y direction. So if we're going to graph point B, we start at the origin, we go -2 to the left, and up 6. This is point B. Point D is -1, -3, so starting at the origin, we're going to go -1 in the x direction, and -3 in the y direction. This is point D. If you'd like to pause the video here, make sure you can graph the next 2 points on your own and then check your work. Point G is at 4, -7, so we're going to go +4 in the x direction and down 7 or -7 in the y direction. That's point G. And point H, we have -5, 0. So we're moving -5 in the x direction and 0 in the y direction. So our point is actually right on that x-axis. Now let's go the other way. Give the coordinates of each point and name the quadrant or axis that it lies on. So first we have the red point. This is in quadrant 1, and if we start at the origin, how do we get there? We go 3 in the x direction, 5 in the y direction. So we would label this 3, 5. This is also in quadrant 1. Let's look at the orange point. I can change my colors here. So if we look at the orange point, if we start at the origin, we are going -5 in the x direction and +4 in the y direction. So the ordered pair is -5, 4. And this is in quadrant 2. If we go back and look at the yellow point is right on the x-axis. So we move +5 in the x direction, and we don't go up or down in the y direction, so that's 0. And an important thing to note here is that if a point lies right on one of the axes, then it does not lie in any of the quadrants. So because this is on the x-axis, there is no quadrant that that point lies in. Now we have the green point. Starting at the origin, we go -4 in the x direction. I know it's kind of hard to see, and down 1. So it's -4, -1. And down here is quadrant 3. If we look at the blue point next, remember you move in the x direction first, and we actually don't go anywhere left or right. We just go down 6. So we move no units in the x direction and down 6 on the y-axis. Again, we are actually on one of the axes, so there is no quadrant to be named here. And the last ordered pair is the purple one, if you want to pause the video and try to name this one on your own. We start at the origin, we're going 3 in the positive x and down 5 or -5 on the y-axis. So we label that 3, -5, and we are in the 4th quadrant. Let's look at some functions that we actually need to graph. When you're graphing a function, you're plugging in ordered pairs, or you're plugging in x values and then getting an output. So for this example, it says generate the ordered pairs for the function y equals 3x, when x is -2, -1, 0, 1, and 2. So I've given you a table here, and all we need to do is plug in these different values for x. So first we're going to have 3 times -2, then 3 times -1, 3 times 0, 3 times 1, and 3 times 2. So we've input our x value. What do we get for y when we do that? Well, 3 times -2 is -6, 3 times -1 is -3, 3 times 0 is 0, 3 times 1 is 3, and 3 times 2 is 6. So we write our ordered pairs as the x, the input, and the y, the output. So we get -2, -6, -1, -3, 0, 0, 1, 3, and 2, 6. Then we need to graph the ordered pairs on the given coordinate plane. So -2, -6, and if you want to pause the video and graph on your own graph and see if you end up with a graph that looks like mine. -1, -3, 0, 0, 1, 3, and 2, 6. When we're graphing functions like this, we do want to connect the dots as best as we can. That should have been a straight line. Mine's not very straight. And make sure you're putting arrows on the ends. Let's look at another example. This function is y equals x squared minus 3, and we're still using -2, -1, 0, 1, and 2. So we're plugging -2 in for x. Now be very careful here. Notice that that x is being squared. So if I'm plugging a -2 in, I'm actually squaring -2. Here I'm squaring -1, squaring 0, squaring +1, and squaring +2. So what do we get? Remember your order of operations. -2 squared is a +4. 4 minus 3 is 1. -1 squared is a +1. 1 minus 3. We want to add the opposite. Those numbers have opposite signs, so that means we actually need to subtract them. 3 minus 1 is 2. But since the 3 is bigger and it was negative, so is our answer. 0 squared is 0. 0 minus 3. Again, we're adding the opposite. So we need to subtract 3 minus 0. We get 3, but the 3 was negative. We have 1 squared, which is 1 minus 3, and we did that one up here. So that's going to give us the same answer of -2. 2 squared is 4. 4 minus 3 is 1. So we have ordered pairs -2, 1, -1, -2, 0, -3, 1, -2, and 2, 1. So if you want to pause the video, graph the ordered pairs, and see if you can generate a graph that looks like mine. -2, 1, -1, -2, 0, -3, 1, -2, I'm going over 1 and down 2, and also 2, 1. This is a U-shaped curve. It's called a parabola, and it's because of the squared on the x that gives it this shape. This is a graph that you'll become very familiar with, but hopefully your graph looks like mine. Last, I want to do an example that has an absolute value, just so that we're familiar with how this works. An absolute value, this function is the absolute value of x minus 2. So we want to take the absolute value of -2 minus 2, the absolute value of -1 minus 2, the absolute value of 0 minus 2, the absolute value of 1 minus 2, and the absolute value of 2 minus 2. Now remember, absolute value means whatever number is inside is going to become positive. If it's positive, it stays positive, but if it's negative, it becomes positive. So first we have -2 minus 2. We want to add the opposite. These numbers are both negative, which means we add them and we keep the sign. So we would get a -4, but we need to take the absolute value. So that means it's going to become a +4 or give us an ordered pair of -2, +4. On the next input of -1, we have -1 minus 2. We add the opposite. Those numbers have the same sign, so we need to add them, and they would get the sign negative since they're both negative. But again, we're taking the absolute value, which is going to make that 3 positive. So the next ordered pair is -1, 3. If you want to pause the video, try the next 3 on your own, and then check your work and see if you get the same outputs or the same y values. Plugging in is 0. 0 minus 2, we add the opposite. Anytime we have the number 0, it's not considered positive or negative. So we're going to take 2 and subtract 0. We get 2. But the 2 is negative. It's bigger than 0. So the answer would be negative. But again, we're taking an absolute value. You can't forget about these absolute value symbols. So we get a positive 2. So our answer is 0, 2. For an input of 1 minus 2, we add the opposite. So that means we actually want to subtract the numbers since they have different signs, +1 and -2. 2 minus 1 is 1, but we would bring the sign down from the 2 since it's larger, but again, we're taking an absolute value. So it's going to give us a +1. So the ordered pair is 1, 1. We also have an input of 2, so 2 minus 2 is 0. When you take the absolute value of 0, you just get 0. So here the ordered pair is 2, 0. So let's graph these points. -2, 4, -1, 3, 0, 2, 1, 1, and 2, 0. Now I should point out what an absolute value function looks like on a graph. Right now this looks like a line, and you might be tempted to draw a straight line like this and give it arrows on both ends. However, this isn't exactly what an absolute value function looks like. So I'm going to erase that, and I'm actually going to do a couple more ordered pairs. What happens if you plug in a 3, a 4, and a 5? If we plug in a 3, let's look at the function here. 3 minus 2 is 1. The absolute value of 1, it's already positive, is 1. Let's plug in a 4. 4 minus 2 is 2. 2 is positive, so when we take the absolute value, we still get 2. 5 minus 2 is 3. Again, the absolute value of 3 would be 3. So now let's graph these next 3 points. We have 3, 1, 4, 2, and 5, 3. This looks much more like an absolute value graph. These are V's that come to a point, and you can see where this point occurs at 2, 0. We're going to work on worksheet 1.8 in class, where you're going to have to do some graphing of points and also of functions. This ends section 1.8.